Right now, we're going to help you on Digital SAT Test 2 Math Module 1 Question 14, which you can find on College Board's website. But before we do that, let's work on another practice question that has the same concept in it, and then we can go to the real deal and work on those same skills. So here we have this question about a caterer that is using chicken platters and steak platters for an upcoming event. And now is a good time to pause this video and try this question on your own. Now, the operation that would allow you to be successful here is a really high level operation, which I would even say is unheard of on previous tests like SATs and ACTs. And that operation is the idea of combining inequalities, of substituting one inequality into another. And let's show you how it goes. So if we just go ahead and say X is the number of chicken platters and Y is the number of steak platters, the question says the total number of platters has to be a minimum of 150. So X plus Y, it can be greater than 150 or equal to 150. It's a minimum of 150. And the total amount of money has to be up to 1,000. So it has to be less than 1,000 or equal to 1,000. And that is composed of our price times quantity statements. So we'll have 475 times X as the price and quantity of the chicken platters, and 950 times Y as the price and quantity of the steak platters. So we've got two inequalities, and we're going to substitute them into each other. Now, before we do that, let's stop and think for a second. What do we want to end up with? We want to end up with the maximum number of steak platters. So we want Y to be our end result. In other words, we need to kind of get rid of X. And when you're substituting, the thing that you want to get rid of is the thing that you should solve for. So let me show you how that works. So take away Y from here. We're solving for X because we want to get rid of X. So right now, X is greater than or equal to 150 minus Y. And here we can take away 9.5Y. And so we'll have 4.75X is less than, actually it should be less than or equal to, because they can spend up to 1,000. So I mean, they can actually spend 1,000. So right now we've got 1,000 minus 9.5Y right here. And next we can divide away that 4.75 because the idea is that we want to get the X by itself. Now, with a lot of the big decimals that you're going to find on the digital SAT, a lot of the time you shouldn't really worry too much about simplifying those. Maybe if you need to at the very end to find your final answer, but one thing that the SAT has done on the previous version and on this upcoming digital version is they give a lot of big numbers and big decimals and sort of intimidating figures. And I say just roll with it. So here we've got the 1,000 over 4.75, and then we've got the 9.5 over 4.75 with the Y right there. So we've solved for X. Now X is greater than this number. So if X is greater, that kind of makes this thing here smaller. And if X is less than this thing here, that makes this thing a little bit bigger. Now, if you're really sharp, you're listening to this and saying, well, that means that those two things really could be equal to one another, because greater than or equal to and less than or equal to, so there's a possibility that they're just equal. But we're going to kind of politely ignore that and focus on the idea that one is leaning on the smaller side and the other is leaning on the bigger side. So if we put that together, we can say 150 minus Y is less than, it's most likely less than because it's on the smaller side, this other expression, the 1,000 over 4.75 minus the 9.5 over 4.75Y. So now we've got our inequality that resulted from kind of substituting one inequality into another one. So a lot of really complicated stuff going on here. But let's go ahead and start solving. So we can just go ahead and try to get rid of our denominator by multiplying both sides by 4.75. So as we distribute here, we'll have the 4.75 times 150, 4.75 times negative y. So we have 712.5 minus 4.75y less than 1,000 minus 9.5y. So when we distributed here and here, those denominators of 4.75 just canceled away with the 4.75 we were multiplying on the top. Now we're just going to try to get a nice inequality to describe this situation. So let's add 9.5y to both sides. And let's also take away 712.5 from both sides. And on the right-hand side, that'll give us 287.5. And on the left side, we've got 4.75y. Now we can divide both sides by the 4.75, and we'll get y is less than 60.5. And so what's the maximum number of platters we could have if our number has to be less than 60.5? The biggest integer it could be, because you can have a decimal steak platter, is 60. And that's the answer to this question. So now let's try that substituting inequalities method on the actual College Board Digital Test 2 Math Module 1 question 14. So this is the question. Now is a great time to pause this video and try this question that came over from College Board. And now that we're solving it, let's just go ahead and say x is the number of small candles and y is the number of large candles. So then we're seeing the minimum number of candles is 200. So x plus y has to be something that's greater than or equal to 200, because the minimum is 200. It could be 200 or it could be a greater number than that. Now the money is a budget of 2,200. So in other words, the amount of money that's being spent has to be less than or equal to 2,200. It has to be under the budget. And money in general on word problems will be composed of price times quantity statements. So we have X small candles, and each of those costs $4.90, and we have Y large candles, and each of those costs $11.60. And so that is our inequality right there. And so now we have two inequality statements that we're going to apply this substituting inequality method to. So we're going to want to get, let's see, the number of large candles as our final result. So this is what we're going to want. In other words, this is what we're going to want to get rid of. And as we said on the last question, if you want to get rid of something while you're substituting, solve for the thing that you want to get rid of. So we're going to solve both of these inequalities. We're going to solve both of them for x. So first we can take away y right here, and we'll have x greater than or equal to 200 minus y. And on the other equation, we've got the 4.9x plus the 11.6y less than or equal to 2,200. And still we're solving for x, so let's take away the 11.6y from both sides. So we've got 4.9x less than or equal to 2,200 minus 11.6y. And next we're going to go ahead and divide by that 4.9. Now don't worry too much, like we said, about simplifying these. The SAT has these really sort of intimidating numbers, And so a lot of the time you can just kind of keep them, unless you're in some situation that requires for you to simplify, like if you're choosing between answer choices. But for now, we can just leave it as x, right here it cancels, is less than or equal to the 2200 over 4.9 minus 11.6y over 4.9. And now when we step back and analyze these inequalities, we have x is bigger than some number. If x is bigger, that makes this kind of the smaller number, and x is smaller than this other number. So if x is smaller, that kind of makes this the bigger one. As we said on the last sample question, we're going to ignore the possibility that they could just be equal to one another, but the 200 minus y is leaning toward the smaller side, and the other more complicated expression is leaning toward the bigger side. So now we've got our main inequality that was the result of substituting one inequality into another. And now we just need to start simplifying this thing. So let's go ahead and multiply both sides by 4.9. And so we've got the 4.9 times 200, which is 980. So we've got 980 minus 4.9y less than, and when we distribute into here and here, it's going to cancel away. 2200 minus 11.6y. So let's go ahead and just add 11.6y to both sides to combine everything and get it all solved out, and take away the 980 from both sides. And in the end, we're going to have 11.6 minus 4.9, which is 6.7, so 6.7y less than 2200 minus 980, which is 1220. And when we divide both sides by 6.7, we get all the way up here, y is less than 182.1. So if y is less than 182.1 and we want to know the maximum number it can be that's still less than 182.1 is going to be 182, and that's our answer for that question. Thanks so much, and have a great day.